Hello students, today we will see another compound of nitrogen, that is nitric acid. So it is HNO3. Let us see the preparation. So first of all, let's see the laboratory preparation, lab preparation. So the laboratory preparation of HNO3, that is heating KNO3, potassium nitrate or sodium nitrate, and concentrated sulfuric acid H2SO4. So this is the laboratory method. So KNO3, that is potassium nitrate and sulfuric acid H2SO4. So on heating these two compounds we will get nitric acid. So NaNO3, sodium nitrate also can be used with H2SO4. So on heating we will get nitric acid. So we can write KNO3 as K plus and NO3 minus, H2SO4 as H plus and HSO4 minus. Here also Na plus and NO3 minus, H2SO4 as H plus and HSO4 minus. So by writing this, it is easy for us to write the products. So here H plus and NO3 minus, that is HNO3. So this is the main product, nitric acid. Here also H plus and NO3 minus, so HNO3, nitric acid, that is the main product. Then the byproducts, here K plus and HSO4, that is KHSO4. So this is potassium bisulfate. In this case Na plus and HSO4, that is NaHSO4, that is sodium bisulfate. So this is the laboratory preparation of nitric acid. So heating KNO3 or NaNO3 with concentrated sulfuric acid. Now let us see the commercial method of preparation of nitric acid or the industrial method. The commercial method or industrial method of preparation of nitric acid. So the commercial method is called Ostwalds method. Ostwalds method or Ostwalds process. Here actually the catalytic oxidation of ammonia takes place. So the catalytic oxidation of ammonia, that is actually the commercial method for the preparation of nitric acid. So let's see the equations. So ammonia gas with oxygen in the air, in presence of catalysts like platinum or rhodium, we will get NO and H2O. So in the gaseous form. Then in the second step, this NO plus O2 gives, this is a reversible reaction, here we will get NO2. So in the third step, this NO2 gas dissolves in water, produces HNO3, the main product, in aqueous form, and NO gas. So these are the steps involved in the commercial method of preparation of nitric acid. Here the conditions required are the important conditions in this case. First one is the catalyst, the presence of catalyst, that is platinum or rhodium. Then second one is the temperature. The temperature should be 500 Kelvin. Then the pressure, it is 9 bar. So these are the important conditions that should be maintained in this reactions. So this is a commercial method, or it is called a Ostwalds method. It is a commercial method or industrial method for the preparation of nitric acid. Now let us see the properties of nitric acid. What are the properties of nitric acid? First point is, it is a colorless liquid. It's a colorless liquid with freezing point 231.4 Kelvin and boiling point 355.6 Kelvin. So it is a colorless liquid with freezing point 231 Kelvin and boiling point 355 Kelvin. So another point is, in the gaseous form, it exists as a planar molecule. It exists as a planar molecule like this. So this is the planar molecule, or this is the gaseous form of nitric acid. So this is the planar structure. Then the next point is aqueous HNO3. Aqueous HNO3 will be a strong acid. So it acts as a strong acid, and this HNO3 in aqueous solution, that means in presence of water, it produces hydrogen ions in solution. We know that all acids in solution produces hydrogen ions, and that hydrogen ion is existing in the form of H3O plus, hydronium ion. So H3O plus aqueous, and the next ion is NO3 minus. So this is the ionization actually. This is a strong acid. It ionizes in solution, produces H plus ions. Actually H plus ion exists, it does not exist alone, that react with or it attach with one molecule of water to produce hydronium ion. So H3O plus is hydronium ion, and the next ion or the rest of the part is NO3 minus, that is NO3 minus aqueous. So HNO3 aqueous, or the aqueous solution of nitric acid is a nitric acid, or HNO3, that is a strong acid. Now let us see another property, that is the oxidizing property of HNO3. This is another important property of nitric acid, that is oxidizing property. So the oxidizing property or oxidizing agent. So nitric acid, that is an oxidizing agent. So with metals, it acts as an oxidizing agent. Also with non-metals, it acts as a an oxidizing agent. So actually this nitric acid will not react with some noble metals like platinum, silver or gold. So it will not react with these noble metals, but it reacts with some other metals, and shows the property of oxidation or oxidizing property. So oxidizing agent, HNO3 is actually an oxidizing agent. That property can be shown with some metals. So we can write the equation. If it is copper, Cu2 plus HNO3 here, or we can write so actually it is with metals, so we can write Cu. So copper metal reacts with HNO3. Here dilute HNO3 is used, dilute HNO3. So that is very important. We need to check whether we are using dilute HNO3 or concentrated HNO3. So in the first case we can use copper with dilute HNO3, and in the second case we can use copper with concentrated HNO3. So in both the cases the products are different. In the first case we can write the salt first. So it will be copper nitrate. So it will be copper nitrate, CuNO3 twice. Here also CuNO3 twice. So in both cases another byproduct will be H2O, and in the first case NO. So the oxide of nitrogen is formed here, NO. In the second case it will be NO2. So these are the products. So if this metal, that is copper metal, reacts with HNO3, so HNO3 here acts as an oxidizing agent. It oxidizes the produced hydrogen. Actually, hydrogen gas is evolved in all the other cases. So if you are using HCl, H2SO4, etc., in that case we know that hydrogen gas will be evolved in this case. And in the case of HNO3, the produced hydrogen is oxidized to H2O, since HNO3 acts as an oxidizing agent. The salt formed is CuNO3 and H2O. Then this is an oxidizing agent that itself reduced. So the oxidizing agent will undergo reduction. So it forms NO. So the oxide of nitrogen is formed here. In this case another oxide of nitrogen is formed. So this is a reaction with dilute HNO3 and a concentrated HNO3. So we need to check whether the question is with dilute HNO3 or with concentrated HNO3. The same is with zinc metal also. Zinc metal. So in the case of zinc also we can use HNO3 dilute and HNO3 concentrated. So in this case also, first of all we can write the salt formed. So ZnNO3 twice. So this will be the salt, ZnNO3 twice, zinc nitrate. Then water is another byproduct in both cases. Then the next byproduct is an oxide of nitrogen. Here it is N2O. Here it is again NO2. So this is the difference. So N2O here and this is NO2. So N2O is nitrous oxide. It is nitrous oxide, or it is called a laughing gas. So nitrous oxide is formed here. So this is nitric oxide. This is nitric oxide. This is nitrogen dioxide. This is nitrous oxide N2O. This is again NO2, that is nitrogen dioxide. So this is the oxidizing property of HNO3 with metals. So with metals, nitric acid acts as an oxidizing agent. So from these equations we can see the oxidizing nature of HNO3, and since it is an oxidizing agent, it undergoes reduction and form any of the oxide of nitrogen. So these are the chemical equations. So you have to balance all these equations. I am not going to balance the equation. You have to balance all the equations. Now let us see another reaction, that is the oxidizing property of HNO3 with non-metals. Next is oxidizing property with non-metals. So in this case, iodine is converted to iodic acid. Then carbon is converted to carbon dioxide. Sulfur S8 is converted to sulfuric acid. Then phosphorus is converted to phosphoric acid. So actually these are the main products in this case. So some non-metals like iodine, carbon, sulfur, phosphorus, etc. reacts with HNO3, produces these type of compounds. So these are the main products. So let us see the equations. So iodine plus HNO3, carbon plus HNO3, S8 plus HNO3, P4 plus HNO3. So in all these cases, we will get these products, that is HiO3, here CO2, here H2SO4, here H3PO4. So this is iodic acid, this is iodic acid, this is carbon dioxide, this is sulfuric acid, this is phosphoric acid. Then water is the byproduct in all the cases, H2O, and NO2 is also there in all the cases. So these are the chemical equations where we can see the oxidizing nature of HNO3 with non-metals. Here also I am not going to balance this equation. You have to balance these equations. Now let us see another property, that is a test for nitrate. That is called the brown ring test. Next is brown ring test. So brown ring test is used in the laboratory for confirmatory test. It's a confirmatory test for nitrate ion. So it's a confirmatory test for nitrate. So here we need to use ferrous sulfate, freshly prepared ferrous sulfate, and a nitrate salt. So the salt is to be analyzed. So the salt is to be analyzed, maybe barium nitrate or zinc nitrate, etc. In all these cases, the nitrate part or the nitrate salt is to be detected, or it is confirmed. The presence of nitrate is to be confirmed using brown ring test. So for that we need to use the nitrate salt with freshly prepared ferrous sulfate solution, and so add ferrous sulfate solution, then we need to add concentrated sulfuric acid along the side of the test tube, along the side of the test tube. So first of all, we will take freshly prepared ferrous sulfate. So we need to add the freshly prepared ferrous sulfate to the salt containing nitrate. So the salt containing nitrate is added with freshly prepared ferrous sulfate solution. Then in that solution, we need to add concentrated sulfuric acid along the side of the test tube. At that time, we will see a brown ring. We will see a brown ring at the junction of the two liquids, that is junction of the solution and concentrated sulfuric acid. So there is an interface between the solution and concentrated sulfuric acid. So we can see there is a solution. So there is a solution that contains ferrous sulfate and the nitrate salt. So in that solution, we will add concentrated sulfuric acid. So in this test tube will contain the nitrate salt and ferrous sulfate. So we will get a mixture. So in that mixture, we will add concentrated sulfuric acid along the side of the test tube. So after that, we can see a brown ring at the junction of the two liquid. That means there will be an interface between two liquids. So there will be an interface between two liquids. Here there is ferrous sulfate and here there is concentrated sulfuric acid, and there is a brown ring at the junction. So there will be a brown ring is formed at the junction of these two liquids. So this test can be used to detect the nitrate salt. That is a confirmatory test for nitrate. So actually the reaction is nitrate salt. Nitrate salt contains NO3 minus, then iron contains, or iron sulfate or ferrous sulfate contains Fe2 plus and H plus from the acid, that is concentrated sulfuric acid. So first of all, it forms Fe3 plus, there is oxidation, then H2O plus NO. So this is the first step. In the second step, this part together form a complex, that is FeH2O 6 times 2 plus, and this NO, it form a complex, that is FeH2O 5 times NO. So this will be the complex which is called a nitroso-ferrous sulfate. Nitroso-ferrous sulfate, which is actually the brown ring. So H2O 6 times 2 plus reacts with NO. That is the second step. So this hydrated part, so this part together form this complex ionic part. Then it reacts with NO, produces the complex ion. So this is a complex ion. So this is called a nitroso-ferrous sulfate, and it forms brown ring in the test tube. So this is about brown ring test. So this is the preparation and properties of nitric acid.